Okay. Okay, so the first topic we want to cover today is CAD. CAD stands for Computer Aided Design. And so this kind of stems from, it's more of an engineering tool. So, you know, if you've seen construction plans, like those are all computer generated now. But pretty recently, you know, relatively speaking, pretty recently, those plans were all hand drawn. So you'd have guys with big drafting tables, you know, kind of like this, but tilted, and they would draft those plans out by hand. And so they could do the work, that wasn't a problem, but it took more time, and there was more potential for human error. So as computers became more available, we started to move to computer-aided design. The advantage is that if you sit down and you've just spent 3 hours drawing plans, and then you take it to, like you're an architect, and you take it to your client, and they're like, oh, I wanted the stairs on the end of the building, not in the middle. Now you've got to go back, redo that whole thing again. Whereas if you're doing it on the computer, you can just make the change without affecting, having to go back and redo the whole thing. Now, computer-aided design kind of falls into two categories. So there's kind of direct modeling, which is, it's basically like drawing. You might be taking like simple shapes and changing them to make other shapes, or combining them to make other shapes. But if you make a mistake, if you need to make a change, you have to go back, you have to undo all of that work and then redo it again. So it's more like I said, it's more like drawing. It's still faster, but it's more like drawing in that if you make a mistake, you have to go back and redo that work. What we're going to focus on today is parametric design. So parametric design is, I tell the computer, I want this square to be 1 meter by 1 meter. And then I show you the drawing, and Sino is like, well, I actually wanted it to be 1 meter by 2 meters. And all I do is I double click on the measurement, I change it to 2, and then the computer regenerates it to be the correct size. Now, parametric design is a little bit slower, but it is easier in the long run for bigger projects, because you're telling the computer to build relationships between like different parts of the design. So if you decide I want this to be twice as big, if you've done your parametric design correctly, you could even do it in a way where you just tell it, like you have a scale factor and you just say 2, and it doubles all of the measurements. So parametric design is slower at the beginning. There's a steeper learning curve, but if you go into an engineering field, is definitely what people will expect you to know. Now, some tools that we're not going to look at, like I said, we're only going to focus on FreeCAD when it comes to CAD today. But some other tools, if you're interested and you're like, I just want to see what's out there, if you have a good internet connection, like a stable internet connection, Tinkercad is a direct modeling tool. It's what I use with a lot of my beginning students, middle school, high school, just because it's very easy. It's kind of like you're taking bricks and just stacking them and making things. It's an easy way to get started, but it is direct modeling, and we're not gonna, plus the fact that it requires an internet connection, I'm not a huge fan of using it here because you can't count on that. But if you do have access to internet, Tinkercad can be a nice way to get started. And it's also, if you're in a position where you're teaching other people, especially in a school setting, it can be a great way to get your younger students started with it. Is another tool that we can use for computer-aided design. It kind of covers both. So it's sort of direct modeling, and it can be parametric. but Blender is used for a lot of things, and it's a huge, we could spend a whole day just talking about Blender. And you can use Blender for CAD, you can use Blender for making movies. Where Blender really shines is if you want to design organic designs or sculptures. And so if you wanted to design, like, kind of picture it as like things that you would make out of clay. So if it was a physical object and you're making it out of clay, okay, that's kind of what Blender is meant for. Whereas FreeCAD is meant to be like, I start with a drawing and then I make it three-dimensional. So there are other tools. You might have, how many of you have heard of like Fusion 360, maybe in like an academic setting, SolidWorks, you have plasticity. There's a lot of different tools. The reason we're not going to cover them is because they cost a ton of money, like a ton. Expensive ones that people use professionally is like, it's like $6,000 for a license. It's ridiculous. You know, you could buy a car instead. And so I'm not going to focus on any that cost money. I'm also not, Onshape is another great tool. And I really mean that, like it's great. But the problem is you need an internet connection and you need to create an account. And if you don't pay for it, there's a free version, but if you don't pay for it, there's what you can do with it. Great tool. I use it with my students, and like I said, you can sign up for free. So if you have access to internet and you want to try it out, it's really good. I focus on FreeCAD is because it's free, doesn't cost any money. Once you've installed it on your computer, you don't, and they don't care what you do with it. So they're not going to tell you like, oh, you're not allowed to use this for work because you didn't for it or something like that. That they just are like, it's yours, use it, do what you want with it. And so that's why I focus on FreeCAD today. And I do this with my students as well. Access to a free tool that's not a bunch of money. So if what we're going to do with FreeCAD is I'm going to kind of do a demo, and then we're going to go to the lab and actually do it. So if you do have your laptop and you are connected, I want you to pull up weekdayweekend.net. That's this in red here, weekdayweekend.net. And then go to the CAD workshop. Now, again, if you don't have a laptop, don't worry. We'll pull this up on the computers in the lab as well. So the author of this website, I've been working with him over the past about a year and a half. He did this project just for fun. He is an engineer. He does CAD for a living, and he wanted to build a website that hosted models for students to practice with. And originally it was, he wasn't specifically targeting students, but I reached out to him and I was like, hey, this is a great resource, my students really like it. Would you consider making a few changes to make it more student friendly? He's been doing that, and I really appreciate the work that he's put in here. So you can see on this website a lot of different models that you can try to make. And like I said, he's focused, and CAD in general tends to be focused more on the engineering side of things. And so these are not like, you know, just for fun. These are supposed to be parts for mechanical objects. And so I want to pause for a minute and talk about like what's the point of CAD like for us. Because at the end of the day, like you need to know like how is this useful to me? What can I do with this once I know how to do it? And so even if you're not a professional engineer, CAD is a huge help for if you need to make replacement parts for things. You can let's go ahead. So a lot of new parts that you can practice with on your own. I will start off with something very simple, and what I'm going to do is actually, I'm going to do the part that we're going to do in the lab. Now when we get to the lab, like I said, if you've installed it on your laptop, you can use your laptop for that part. If you're using one of the lab computers, we'll install FreeCAD, and then we'll actually go through the demo. So let me pull up part 8. Now his goal is that like you practice making the part and then you try to get faster and faster. Now it's just for fun. It's not like there's a prize or anything like that. It's just that you are getting quicker and finding other engineers faster ways to model, better ways to model. And so the goal here at first is, and then you worry about your time. Now I'm going to go here and I'm going to go ahead and install an add-on. And again, we'll do this in the lab too. And what this add-on would let us do is figure out the mass of an object that we've designed. Okay, so I'll let code. All right. So this add-on just lets me tell like how heavy it is when I'm done with it. So I'll add that. Okay, so I'm going to go ahead and start with what's called a parametric body. So in CAD, you have bodies that are like three-dimensional objects in a project. You can have more than one. If you called an assembly, we are not going to do an assembly. It's like once you've gotten comfortable with this, then you can move on to doing assemblies. So I go ahead and this intentionally because I want. Okay. Now, I think, if I'm not mistaken, those of you who have laptops, I think all of your laptops probably have a faster processor I'm working with. I've done this intentionally because I want to make sure everybody understands you can do this on very low-end computers as well as high-end computers. You don't need a gaming PC to do CAD work. Conception, sometimes when you talk to engineers, they'll kind of like, oh, you gotta have an RTX 5090, like you gotta have a gaming PC. No, you don't. Will it be faster if you do? Sure. But I can't afford that kind of equipment. Okay, and so I don't do my work on kind of equipment. I do my work on whatever I have handy, and I want to make sure that that's something you realize is like accessible. So, like I said, CAD is space. So you start an object by starting a drawing. So I'm going to click New Sketch, and then I'm going to choose X, Y. So basically, if you look at the screen there, and let me know if I'm in your way, okay? Because I can move over. The X, Y is like it's on the table, okay? It's like this is the X, Y plane, okay? And X, Z, and Y are vertical. Okay, so I tend to design things in the XY plane because I tend to 3D print things. So back in the US, in my classroom, we have 3D printers. Most of what I'm doing is teaching students how to design, and then they 3D print their designs. So because printer prints on the plate, builds up, I tend to design that way. So I can do my best to make designs that will print well. So I'm going to select XY, okay? Now, if you've got FreeCAD pulled up already, I like to use the Blender preset, mostly because I also use Blender for teaching, and so it's familiar to me. But I also think the controls are a little bit better than the default CAD setting. I also like to use a mouse. Now I have students who are like really great at using the trackpad, and they can do it really well and really precisely. you'll see some engineers who have like a mouse that's got like buttons. You can do that if you want, but I just keep a simple mouse around for my design work. So I'm going to go ahead and left and right click at the same time to pan over, center this. And then I'm going to go ahead and draw myself what's called a centered rectangle. So centered rectangle, I pick a spot, and it's a little hard to see, but there's a little pop-up that when I'm hovering over the center origin, I get a little crosshair. And if I click, the shape is kind of stuck to that. Now you can see down below and to the side I have measurements. Now it's considered, even in the US, depending on what field you're in, sometimes people will use imperial units, feet and inches. Most of the CAD work that I do, almost all of it, I would 99% of it is metric. And so I'm used to working metric for my CAD design. That's the standard here. And so that's the way it's set by default. If you change it, you're like, you know, I'm working in a country that uses imperial. You can just go down here and choose the units that are appropriate to work. So I'm going to go ahead, start where, but I'm not going to click yet. I'm just going to go ahead in measurements. But if I go back here, I'm going to pull up the actual drawing, okay? So this drawing tells me that my cube should be 50 millimeters on each edge, 25 diameter holes going through each side, okay? And then a 2.5 millimeter fillet, and a fillet is just a edge. 2.5 millimeter fillet on all 12 edges, and then this is what it should look like when I'm done. Okay, so my important measurements here: edge length is 50, circle diameter is 25, fillet is 2.5. So I'm going to go ahead. All right, so what should my dimensions be for this square? 50. I'm just going to type in 50. I'm going to hit tab and type, and then I'm going to lock it in. I don't necessarily have to do it that way. Over here, I'll do another one. So I can just click and drag, and then back pressing D, I can go back and set my dimensions afterward. So if you prefer to just kind of like get and then go back and put in precise measurements, you can. It's up to you. There's a lot of different workflows you can use, so don't feel like you have to do it once on basics. So my drawing is done. You see it's green. What that means is it's fully constrained. So full constraint means there is no other way the computer could make this shape. So something is not fully constrained. Let me go ahead and draw another square over here. So if something is not fully constrained, I can take it and change the shape. If I try, it won't move because I've told the sides have to be 50. They need to be horizontal and vertical, and they need to be locked to this center point. So there's no other way the shape could be drawn. It could be this way. Now, do you have to constrain your shapes? No, but it can lead to, and if you're doing this professionally, you'll be expected to constrain them. Just designing for fun, sure, you don't need to do that, but professionally, you have to fully constrain your shapes. So I'm just close it. What shape do I need? I have a square, but I need what? I need a circle. And then what shape is this overall? Because it's not two-dimensional, it's dimensional. So we've got a cube here, right? And so how do I take this two-dimensional square and turn it into a three-dimensional cube? I'm going to use, I'll select my sketch, and I'm going to, now, this is the thing, if you're taking notes, this is one thing to note that FreeCAD calls a different name than tools. So in FreeCAD, it's called padding. In other tools, it's called extruding. They do the same thing, okay? It's just different words for the same idea. So if you're using something like Fusion, you extrude, not pad. So I click pad, and I get a little preview of what the shape looks like. I'm telling it, extrude this or pad this 10 millimeters up, but I want it to be 50 millimeters so that I have a cube. And then I click OK, and now I'm done. I have a cube, okay? So the next I want to do is go ahead and start doing my circles. So I'm going to pick one face. Let's just start with the top. So it's turned green, which means it's selected, and then I hit New Sketch. So when I do that, I'm basically saying to the computer, draw this next drawing on that surface of the cube. Okay. So I need a circle. Now here I could kind of cheat because the circle is centered. If I go back to the drawing, the circle is centered on the face. Okay. I could just cheat and then center it here on the origin, set it to 25, and call it a day. Okay. So I hit those. Now I have the circle, a two-dimensional circle. And then I need to make a cylinder, a hole through this cube, and that's where the pocket tool. Now, if you're looking on the screen, you see there's pocket, but there's also the hole tool. So this is another thing where I wish FreeCAD would kind of name it a little differently, because hole is for cutting holes for like screws, whereas pocket is just I want to carve away from this shape. So I'm going to go ahead and use pocket because this is not really a hole for like a screw. Though, you can set to like the exact type of screws that you need, and it will calculate everything for you. So you don't have to like guess how big everything should be. So I start the pocket tool, and you can see this if it was 5 millimeters deep. Now it needs to be 50 millimeters deep. So I type in there, and it goes all the way through. Now I'm going to do this so you can see that it works. So you can see that hole goes all the way through. The next ones though I'm going to do differently because if I change the shape of, let's say I take it, show it to Sino, and he's like, okay, great, but we actually want the cube to be 100 millimeters. What am I going to have to do to the hole? To make the cube, I'm going to have to do what to the hole? Yeah. Not the world, not a huge deal. Still easier than, but it's more steps than we have to take. So I'm going to show you a better way to do it that would recalculate the hole in the cube here. So I'm going to go ahead, select another face, create a sketch. Now the problem is, this time I can't just cheat and link that hole to the origin. I have to come up with a different way to lock it of my face. So what I'm going to do is I'm going to use what are called, so I'm going to press the G key and the X key, and what that does is it brings in the edges of shape I click on and use them in this drawing. The problem is they're solid, which means they're actually there, like they're actual lines. So I'm going to undo that, and I'm going to click construction, and what this does now, when I click GX, is it creates dashed lines. That means they are there as far as the computer is concerned. The computer sees them, you can see them. You go to actually make the shape, you won't be able to see them. And so what we can do is use them for calculations, we can use them for our equations. So I've done these, and I'm just going to make diagonal lines from corner to corner. I'll switch back to, which is like, it will actually be there, and I'm going to circle. Now, I am not going to bother, I'm really worried right now about making that circle the right size. I don't really care where it, and you can see because I drew it. See, if I try to move my mouse, it's stuck to this line. I don't want that. I want it to be attached to the line, not the edge. So constraint that I don't want, okay, I can go down here and then just delete it. Now when I go to move this, I move it freely. Okay, so don't encourage you to try and get everything right the first time. Over time, you'll better. But what I'm going to do is I'm going to use this tool right here. It's called coincident. So it just means that a point on an object has to be some other point or an edge. So I'm going to, and then I select the middle of my circle line. So it jumps over, the computer recalculates it and says, okay, if the circle has to be touching this line, now when I go to move it, it's locked to that line, but I also want it to be locked to this line. So I'm going to go back to my coincident tool. Now it's locked to both lines. So this circle has to be touching both lines. The only place it can be is right in the middle. And so now it's fully constrained. Now, there are other ways to do this. On-shape confusion give you other options, and even in FreeCAD, there are other ways that I could have made that circle stay in the middle. This is the old way of doing it. It's also just very easy to understand. And so start with simple things. As you get better and better, you can try out fancier techniques to do your work. Fully constrained, so I'm going to go ahead and close. And this time, I'm going to say, instead of type dimension, I'm going to say go up to a face. What this does, when I select it, I rotate around and tell it, I want you until you get to this. Okay? Now, if I change the size of the cube, it would keep going until this face. I'm going to go ahead and do this last one here. So I switch to constructions. Then I switch back to real ones, set to 25. Constrain it. Pocket. A face. Okay. Now, there's one thing I haven't done yet, which is always a good idea to do when you're working on a project. Save my work. Now, some tools like Onshape will save for you automatically, which is really nice. But I'm going to go ahead and save this, and I'm just going to call it part 08 because that's, yeah. So all the sides are the same, and I can actually go here using the measure tool and check my work. So if I click this edge, I can see it's 50 millimeters, 50 millimeters, 50 millimeters. And if I check my drawing here, okay, there's one thing missing. Yes. So the basic geometry is there. It's the right size, but I need to go ahead and add these fillets. Now there's two ways that you'll see this done. There's fillets, which is a radius or a curve, and there's chamfers. So a chamfer is like you just took a razor blade and slice off the corner at an angle. And so depending on what you're doing, chamfer or fillet, you'll just choose what you need to use. In this case, we have to use a, because that's what the drawing specifies. Okay? So I'm going to go here, and I'll go ahead and close the measure tool. Now, I'm not going to select anything. I'm just going to go ahead and open up. So if you look up here, the fillet tool, the chamfer is the other alternative. So fillet, and I'm just going to go ahead and start picking edges. You can see it start to preview. Now, if you're on a slow laptop and it's really black, you can turn off preview and it will be faster. Okay, so I just pick edges. Okay, as I rotate the object around, all of my edges are picked except for the edge of the circle. Now, the radius of my fillet would be 2.5, not 1. So 2.5. I hit OK. So I'm going to go ahead and center design. Click on the corner. Okay, and I can see comparing it to the finished product here and here that I've designed this correctly. Now, if I want to be really sure that I've done it correctly, okay, I can use, so I've got my body selected, and I can use FC info to check that. Okay, so let me give this a minute to render. Okay, and he's given here like tolerance of 0.02 grams. That means that if you did this correctly, your design, you can, like, you'll be within 2/100ths gram on the mass. Okay, so let's see, our material, I'll check. He wants it in ABS plastic. So let's see, does he have plastic? Is that in here? Okay, so I forgot in the default settings for FC info, it doesn't have plastic. So we'd have to add that. If this was, let's going to illustrate here, because I want to take the time to say we made this out of oak. Okay, so if it was made out of oak, the cube would weigh 50 grams, 50.8775. So you can kind of predict, and this is again where the engineering side of it comes in here, or this is what it's for, is that I can say, like, here's my design, and I go hand it to the machinist or the carpenter or whoever, and like, if you do this correctly, when you're done, it should be between 50 and 51 grams. And so if it's significantly heavier or lighter, follow those design specifications. Now, another way that you can obviously check your work in the physical world is with calipers. Now, this is the one thing, if you go into CAD, whether it's for just personal, like you just enjoy it, or whether it's for work, get yourself a pair of calipers. This is I like telling people to buy the tools because it costs money, and if you don't end up using, and then you feel like you've wasted time or you've wasted effort getting them. But this is one that always come in handy, because what calipers let you do is I can take a real world object, so I can say, if I want to design a clip to hold a marker, I don't know, a magnet to hold it on the whiteboard. So I take these calipers, okay, and I can get a measurement off these. These are 16.97 millimeters, or round up to 17 millimeters in diameter, okay? And they can, depending on how you get, they get pretty big. I get a measure. This is 134.9 millimeters long. So what I could do is in FreeCAD, I can take this measurement and start to design a replica of a real object. So let's say a part on my bicycle, and I want to make a replacement. I take my calipers and I measure the bike frame where I need to build that replacement part, and I get those measurements. I always recommend writing them down because you don't want to forget to go back constantly. So I get measurements, I write them down on my computer, and I sort of build a replacement based on my real world measurements. So if you get yourself a pair of calipers. These are like, in the US, $10 US, and I recommend cheaper ones made out of plastic. Problem is that when you're getting measurements, plastic is more likely to bend, so you'll be a little less accurate. But I recommend just get a cheap set of metal calipers, and you'll cover a lot of the tools that you need. Because you can also use this as a ruler, and this is so if I wanted to figure out how deep a hole is, I can just set that and get my measurement off of it. Okay. So I bring this here, and I just extend it down to the bottom, and I know that hole is 7 millimeters deep using the depth gauge there. Okay. So they're not, and you're going to spend money, spend it on this as your first tool for CAD. There's other stuff that is helpful, but that's going to give you the most utility. Yes.
Speaking about the method, the object is made of wood and metal. Sometimes how do you?
So that's a great question. If you have an object made of more than one material, you can, first of all, you would be looking at, let me go ahead and close this. You would want to have more bodies. So you would have one body that was the wood. We wanted to make a cube that is wood. The base in the middle is metal. So the body was set to, it's made out of wood. I would create another body that fills this space here, that is metal. And so then I could calculate those separately. So you use multiple bodies. And kind of think of it as, if it's made, that's one way to think about bodies that work in FreeCAD and other tools. If it's made out of different materials, and then we bring them together as an assembly. I don't think we'll have to get into assemblies today. I'll cover that, but starting out with bodies, get comfortable, and then move into assemblies. And I do want to recommend, so there's some resources that I let's pull them up here on the laptop. Okay. So, Seth, can you just hide the screen source there with a little eye? Okay, good. Yeah, that's fine. I'm not worried about the projector. I just don't want it in the recording. So there are a lot of good tutorials online for FreeCAD. Now that we have good internet access here, obviously here is a great place if you need to look stuff up. It's a great resource. There are tools you can use to back up there we go. YouTube videos, but if you can come here to the city office or you have internet access on your phone or at home, these are good sources. Now don't worry about trying to copy these down. I'm going to put these into the WhatsApp for anyone who needs them. So Seth, you can go ahead and put that back in the recording. So these 4 sources are not the only ones, okay? I would say the 2 best for learning FreeCAD are these. Now, I don't know why this is called Mango Jelly, but Mango, that would work. Just look up, and then you can see, and you know, from time to time, this is an older version of FreeCAD. Now, what I want to do is go ahead and let's kind of stop the recording here, and then we're going to go to the lab and try to do this together. Now, who's planning on using their own laptop to do this? Anybody? Okay, so if you're not planning on laptop, that all go through the process of downloading FreeCAD, putting it on the computer, and then designing a cube. Okay, so we can go ahead. Did you stop the recording, Seth? Okay. So we can go ahead and take our things into the lab. Where did I put the case? Sorry, you're just gonna. It's just gonna. Okay. Where the case went? Sooner, did you see where that was? No. Okay. Oh no.